Hello friends, today we will be looking into the role of statistics in the real world case scenarios. The case study that we will be discussing today is like, does stents prevent the risk of heart strokes? So before we go into this, let's understand what is a stent. Stent is basically a medical device that is put in the blood vessels near the heart to prevent the risk of any heart strokes in the patients who have already faced heart strokes. So what researchers did over here, researchers conducted an experiment by taking 451 users, or like 451 at risk patients who are like at the risk of heart attack, and divided them into two groups. One is like the treatment group and one is the control group. In the treatment group they kept around 224 patients, and in the control group they kept 227 patients. All the patients in the treatment group were given the stent stents were like implanted in these patients, and the patients in the control group, they were not given stents, no implantation of stents. So now two group has been created. The control group is basically our reference group, and we look into how our treatment group is performing by comparing it with the control group. So researchers over here monitored the patients for 30 days and 365 days, and each patient has been tagged to a treatment group or a control group, and they would see like whether in the first 30 days they have gotten a stroke or not. Given like the people in the treatment group have been implanted a stent and the people in the control group have not received any stent treatment. So this kind of table is hard to summarize. So we have converted this one into a 2 by 2 matrix where we will be looking into the control group in the treatment group, and within 0 to 30 days we will see like how many people in the control group in the treatment group have gotten a stroke, or they have no occurrence of stroke. Similarly, between 0 to 365 days, we will also look whether the people in the treatment and control group have been exposed to a stroke, or like there is no stroke within the 0 to 365 days. So we will be looking into like this 0 to 365 days of event, and we will be calculating from here the proportion of stroke event in the treatment group and the proportion of stroke event in the control group. So our summary statistics is proportion of stroke event. So in the treatment group, if we see the proportion of stroke events, if we yeah, so if we zoom in, we can see like in the treatment group, the proportion of stroke events is 45 divided by 45 plus 179, and in the control group, the proportion of stroke event is 28 divided by 28 plus 199. So around 20% of the people in the treatment group who have undergone through this stent implantation process have received a stroke event. Around 12% of the people in the control group who never underwent through any stent treatment have received a stroke. The stroke event for treatment group is around 20%, and the stroke event for control group is around 12%. This is quite counterintuitive, as doctors thought that stents are meant to reduce the stroke event, not increase them. So there is a 8% difference is what we see. So there are 8% more people in the stent group who had a stroke, and that's surprising. To understand this 8%, I would like to draw an analogy of like flipping a fair coin. So when we flip a fair coin, the probability of getting heads is 50%. So what does that mean? That means like suppose you flip a coin 100 times, ideally you should get 50 heads, but that's not the case. You can get 40 heads if you flip a coin 100 times in in one experiment, and in another experiment when you flip a coin 100 times you might get 60 heads. So there will be always this kind of randomness, or we also call it as uh, random natural variation. So we have to figure out now whether this difference of 8% can that be attributed to random natural variation or luck or by chance, or is there something real going on in behind? So the question over here right now that we have in hand is like, is the 8% difference real or could it have happened by chance? If the answer is yes, then it's a true effect. And if the answer is no, then it's not a true effect and it has happened by chance. Now, if it is yes, it's a true effect, then the results are concerning. And we should be concerned because our treatment group is not performing better than the control group. The stunts are not reducing the risk of heart attacks. But if the answer is no, which means like it's not a true effect and it has happened by chance or like the randomness, then we can say like our stunts are performing good and our treatment uh, group is performing better than the control group. But over here, what researchers found is like they used some statistical methods like significance testing, which is coming from the statistics, and they reached to a conclusion that yes, it's a true effect. And in this particular case, the stunts are not performing good, and the treatment group are performing worse than the control group. S- But later on, they found out that here there was a condition that all the stunts that were used was coming from a particular manufacturer, and that that could be a case like uh, there are like better manufacturer and better stunts available in the market. If those are used, maybe like this experiment could be different. So we saw in this particular case how statistics actually helps. With that, I conclude. Thank you.